Okay, so in this video I'm going to have a look at cubic functions. So I'm going to have a look at what a cubic function is, the basic cubic functions, transformations of cubic functions, and how you draw them and sketch them. So let's have a look at our kind of definition of a cubic function, if you like. Our cubic function is going to look like this. It's going to be, we'll call it f of x, and it's going to have an x cubed with some number in front of it, this coefficient here, and then it can have a bx squared plus cx plus d. So the a, b, c and d here are just numbers, constants if you like. So this can be 5, this could be 3, this could be -2, this could be 10. These can be any numbers you like, or indeed these could be zeros if you like, except for a can't be 0. So the idea is that you have an x cubed here anyway. Now your basic cubic function is just, we'll call it f of x again, it's just x cubed. So in other words, b it would be 0, c would be 0, d would be 0, and a here would be 1. So this is your x cubed function. I'm just going to sketch that first up here. So let's have a go at that. Now if we take it's just f of x is equal to x cubed. So if we start with 0, for example, 0 cubed is just going to be 0. So we're just going to end up with 0, 0 here. If we take 1 and cube it, we get 1 times 1 times 1, which is just 1. So that's going to be somewhere around here. If we take 2 and cube it, we get 2 times 2 times 2, which is 8, which is about 5, 6, 7, 8, about here. And if we take 3 and we cube it, we get 3 3s are 9, 3 9s, 27, which is about here. Now it's going to be the same on the other side. I mean, if we take -1 and cube it, we're going to get -1. If we take -2 and cube it, we're going to get -8. So that's about here. If we take -3 and cube it, we're going to get -27, which is down here somewhere. So you can see the way the curve works here. It comes down. I'm going to draw this freehand now, so let's see how this goes. It comes down here. Now it flattens out at 0. You get this, what's called a saddle point here if you like, and then come down here, and we'll end up down here. So this is our curve here. Our basic y is equal to x cubed curve. Now what happens then if we change that slightly? So let's say we take our f of x, and let's say, so we take our f of x and we put a number in here instead of 1. We'll, let's say, put in 2. So let's say we use a 2 here instead of a 1. So the coefficient of x cubed is 2. What happens to this function here? Well, let's draw it. Now if we take 0, we're going to cube it first, so that's going to be 0. Multiply it by 2, that's going to be 0. So we're still going to end up here at 0 for 0 as our x value. What about 1 then? Well, if we cube 1, we get 1. Multiply it by 2, we get 2. So if we put 1 into our function, this time we're going to get 2. So instead of being here, we're going to be here. If we take 2 and put it into our new function here, we'll get 2 cubed, which is 8. Multiply that by 2, you get 16. So instead of 2 being here, we're going to be up here at 16. And 3 cubed, instead of being 27, is going to be 54. So I don't have that on scalar, but it's going to be way up here somewhere. Now same on the other side here. We're going to end up with -1 is going to be down here at -2, and -2, when we put that into our function, we're going to get -16, which is here. If we put in -3, we're going to end up with -27. So our function really is going to look something like this. Our graph of this function is going to look like this. Again, it'll flatten out here at 0, and then it'll come down here and go down to -27. So you can see what happens here when we put in coefficient of x cubed here that's greater than 1, we're going to move the these arms inwards like this. I'm going to move it inwards in that direction. The 0 will remain the same here, this point here. Now, if we had to put in, I should say, a half here or a quarter instead of 2, what would happen is the arms would move out this way. So it would move out in the opposite direction. Okay, so that's what happens when you put in a larger coefficient than 1 here in front of the x cubed. So what happens if we do something like this? We'll call it g of x this time. We'll just change it slightly. And this time, let's say we do, let's say x cubed plus 3. So what happens if we do this? If we, instead of putting in, we leave the coefficient the same here, so it's not changing. We still have a 1 here, but we are adding 3 to our x cubed function. So this is our basic function, which is in red here. What happens to that red graph when we just add 3 to it? Well, really what's going to happen is all of these y values that we had originally are just going to increase by 3. So in other words, let's pick a different color here. So let's say we have 0 and we put it into this function. Well, 0 cubed is just 0, add 3, we get 3. So instead of this point here being at 0, we're now going to be at 3. Instead of 1, 1 cubed is 1, so we ended up here. Add 3, that's going to bring us up to 4, so it's up here. 2 cubed here was 8, add 3, and we end up at 11 here. So we're going to end up here. Sorry, 2 cubed, 2 cubed is 8, 2 2 is 4, 4 is 8, add 3, we get 11, yep, so we're going to end up here. And 3 cubed then is 3 3s are 9, 3 9s 27, add 3, we get 30, so we're going to end up here somewhere just off the screen. It's going to be up here somewhere. Same on the other side here. So let's pick minus 1 here. Minus 1 cubed is minus 1, add 3, we get 2. So we're going to move this up 3 places, so 1 2 3, so we're going to end up here. Minus 2 cubed is minus 8, minus 8, add 3, you're going to end up, instead of being here at minus 8, you're going to end up here at minus 5. Minus 3 was minus 27, move that up, it's going to be minus 24 here. So you can see the way the curve has gone. You have just moved the entire curve up 3 places. So we're going to end up with something like this. This is from the red curve now. Okay, so the entire curve has moved up 3 places. Okay, so that's what happens if you just add a constant to the function x cubed. Now we'll just do one more. It's getting a little bit crowded here, so we'll just do one more. Let's take, we'll call it h of x this time just to change it again. Let's say we have our x plus 2, or we'll actually change that, we'll make it a little bit bigger, I think. Let's say we'll take x plus 5 and we'll cube that. So this time we're adding a 5 to the x and then cubing it. We still end up with a cubic function here because we're multiplying x by x by x here, so we'll still end up with a cubic function, but we're putting the 5 inside the bracket here, so we end up with x plus 5 cubed. What does this do? This actually moves the entire graph, the entire original graph x cubed, to the left 5 places. So this is going to move the graph to the left 5 places. And also, if this was an x minus 5, it would move the graph, the original graph of x cubed, to the right 5 places. It's kind of the opposite to what you might think. So if we add 5 to the x and cube it, this red graph was just going to move to the left 5 places. So our 0 here would end up 1, 2, 3, 4, 5 here. This point here would end up here. I probably should have picked a smaller number actually. Let's do let's just change that slightly. Let's say instead of 5 there, we'll just go with let's go with 3. So I'm just going to change that to a 3 here. So x plus 3 cubed. So this would go to the left 3 places, so it would end up, let's do it in this color here. So let's say that will end up going to the left 3 places. So this red dot here will end up here. This one here will end up 3 places to the left, 1, 2, 3 here. Our 2 cubed was 8, which was here. That will move to the left 3 places, 1, 2, 3, so that will end up here. And our 27, our 3 cubed was here. That will end up 3 places to the left, 1, 2, 3, which is here. Similarly to the ones on the left hand side of the y-axis, so this minus 1 here will end up 1, 2, 3 here. Minus 2 cubed was minus 8, so this would end up here, 1, 2, 3 to the left here. We're just going to go off screen then for this one here, but you can see that the graph will look like this. So it's just this red graph here moved to the left. We moved it to the left 3 places, so that's what this here will do. Okay, so that's just some of your basic transformations of cubic functions. Let's have a look at an actual function then, and let's just draw it. So I'm going to look at this particular function here. I'm going to look at f of x, we'll call it, and it's going to be x cubed minus 4x squared plus x plus 6, plus x plus 6. Now what I'm going to do is just simply draw this particular function. I'm going to draw this here. So how do you do that? Well, you can put this into, well, some calculators anyway. You can stick this into your calculator. It'll give you a table of x and y values, and you can just plot them. I'm going to do it manually, so I'll do that. I'll do it down here. So let's say we have our x values. We have our function, which is x cubed minus 4x squared plus x plus 6. We have our y values, and I'll write down the points as well. Now I'm going to draw this particular graph from minus 2 up to 3, and I'm going to do these, I'm going to step these up in 0.5. So I'm going to go minus 2, minus 1.5, minus 1.0, minus 0.5, 0, 0.5, 1.0, 1.5, 2.0, 2.5, and 3.0. So these are my x values. Just stick these into this function here, work out what the y values are. So I'm just going to do 1 or 2 of these. I'm not going to do all of them because it's just repeating the same thing over and over again. So I'm just going to stick this minus 2 into this, so that'll be minus 2 cubed minus 4 times minus 2 squared plus, and again in brackets here put in the minus 2 plus 6. When you do that, you get a y value of minus 20. So the point here would be minus 2 minus 20. So that's my first point. You do the same with each of these. So you put in minus 1.5, cube it. It's minus 4 times minus 1.5, square it, put in the minus 1.5 here again in brackets, plus 6. And when you work this one here out, you can do this on your calculators, you get minus 7.9, minus 7.9. So this second point here would be minus 1.5, minus 7.9. And so on. I'll just write in the other points. The next one would be minus 1.0, and it is 0. Next one is minus 0.5, and for minus 0.5 we get 4.4. For 0 we'll get 6. You can see that anyway. If you put a 0 in here, 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 and you'll just end up with 6. For 0.5 we end up with 5.6. For 1.0 we end up with 4. For 1.5 we end up with 1.9 as our y value. For 2 we end up with 0. And let's see, we have 2 more to do. We've got 2.5, which is minus 0.9, and then we end up with 3 here, which will give us a y value of 0. So these are all the points we need to plot. Okay, so I'm going to plot those here and draw our curve. So let's have a look. We have minus 220, so that's going to be minus 2 here, and we have minus 20 down here, so we plot that down here. We have minus 1.5 minus 7.9, so minus 7.9 is about here. We have minus 10, so that's going to be here. We have minus 0.5, 4.4, so 4.4 is around here. We have 0.6, so that's here. We have 0.5, 5.6, so that's going to be around here. We have 1.4, 1.4 is here. We have 1.5, 1.9, so 1.5 and then 1.9 is going to be around here. We have 2.0, so that's going to be here. We have 2.5 minus 0.9, 2.5 minus 0.9 is going to be around here, and then we have 3.0 here. So this is our cubic curve. So it's going to look, again, I'll try and draw this freehand, so let's see. We're going to come up here, come around the top here, back down, and back to 0 here. So this is our curve, this is our function here. Now just one last thing before I finish up. Let's say, for example, now this is our function, this was our f of x is equal to x cubed, this is x cubed minus 4x squared plus x plus 6. Let's say you were asked to draw this, which we've done, and then we were asked to sketch another function, and let's say that function was, let's say, x cubed minus 4x squared plus x plus let's say 4. So you can see here this function here, the two functions that we have here are practically, well, they're the same out to here, but the 6 is reduced down to 4. In other words, we've taken this function here and we have effectively subtracted 2. So you just simply subtract 2 from each of these y values. So we've taken our function and we've subtracted 2. So all of these y values are going to reduce by 2. So you should end up with, I can't do this one here, I'll go off screen, but this was roughly minus 7.9, so that's going to end up somewhere around here. This one is 0, so it's going to end up here. This one was here, so it's going to end up, that was minus 0.5, so that was 4.4, so that's going to be 2.4, so it's going to be somewhere around here. This was 6, so that's just going to end up here at 4. This is going to go down from, let's see, that was 0.5, which was, let's see, that was 5.6, so that's going to be 4.6, 3.6, so that's going to be somewhere around here. The next one was 1, which was somewhere here around 4, so that's going to be somewhere around here. This is 2 or just under 2, which is 1.9. So if you go down 2, that's going to be just down here. 2 is at 0, so that's going to be minus 2. This was minus 0.9, so that's going to be around 2 is minus 2, so then this is going to be minus 3, that's going to be somewhere around here, minus 2.9, and then this was 0, so it's going to be here. So if we connect these up, you can see you'll just end up with a curve like this, which is just the red curve, our original function f of x, just moved down 2 places. We've subtracted our function, we subtracted 2 from our function, so we've just moved the entire curve down 2 places. Okay, so that's it for cubic functions.